Hey everybody, this is Alex Merced from alexmercedcoder.com, and this is going to be my second take on doing a video on objects, just because my computer decided to restart on my previous take, unfortunately. So I will leave the code that I had used for that take here in case anyone wants to refer to it. Yep. Okay, I mean, I'll go through all these concepts again, but yeah. Okay, so I'm going to create an objects2 file. And that's going to be a Typescript file. Because again, it's always easier to learn things in Typescript and then go backwards and realize that to do the exact same thing in JavaScript is just don't do the typing part. Okay, it's literally the only difference between the two languages. Okay, and also how you run the files. Because again, you can run JavaScript files with Deno or Node, but only Deno can natively run TypeScript files out of the box. You would have to have some sort of setup to compile with Node. Usually when you need to, it won't be a problem because you're going to use some sort of framework or something that's going to have that all set up for you. But since we're just kind of doing raw scripting, we're going to use Deno for our TypeScript files. But what is an object? So we learned in previous videos that an array is a list of items. So I can be like 1, 2, 3, 4, 5, 6, 7. And notice I don't have to give a title for each one. Like they're in an order. So all of them automatically get like a label. 0, 1, 2. That's referred to as their index. That's great if I have a list of things. So think about anything you have a list. Like think if I have a list of students in a classroom. Okay, I have a list of inventory. Those are perfect. But what if I want to describe one thing? So I want to describe what one student is like. I want to describe what one student is like. So each of those students in the list would get it, have a name and an age and all these things. Well, in that case, that's where you're going to want an object, because an object is going to allow you to. It's really more for describing what a thing is, because you're describing the values, and they're not in a particular order. You're not saying, hey, I have a list of values or things that describe me that's in a particular order, but I have things that have certain names like name, age, hair color, etc. Okay, and so they're not ordered. So instead of having an index, they're going to have a key, which is going to essentially be a word that describes what that value is. So for example, let's say we're talking about students. Okay, and we have a student named Tim. Okay, so we say const Tim, which we'll say is an object. We'll type it as an object at first. Okay, and then we'll say Tim object, and then we're going to say equals. And then an object, instead of using square brackets like we did in an array, you use curly brackets to define an object. Cool. And see, so right now it's happy with this. I said it's an object, and it equals an object. Cool. But the thing is that that's not really useful. Tim should have a name, so let's add a name. Okay, so we're going to say name. So that's the key, meaning the way we access the property. Kind of like, if you go to a post office box, you have a post office box number. In the right post office box, I'll find the right things. So under the right key, I will find the right value. In this case, Tim is the name. Okay, so there's our object. And see, it's kind of happy with this. That's fine. Okay, now if I sit there, and then that's all good. This is an object, and I can console.log the object. So I can console.log Tim. Okay, and I shouldn't run into any particular issues so far. So if I do Deno run objects2.ts, and see, I log an object, and see, I get the object, and I can see the properties of the object. So it has one property called name, Tim. Now, what if I want to access just that one property? I don't want to see the whole object. I just want to access name. And let's say Tim also has a property called age. That is, let's say 14. Okay, so there's the object. Okay, so usually if I want to access one property, what I would do is I would just say the name of the object, Tim, because that's the object we created, and I would use dot notation to access the property. I would say, okay, problem is, notice nothing, I don't see age, name, or age. The reason is that it's using the definition of an object, and an object is just an empty object with the default functions that are built into objects. So this is not going to necessarily watch. It's going to, if I try to do name, It's like, I don't like this type. This doesn't exist on an object. Okay? Because technically, really, this is the object prototype, not a typing of object. So it's not going to like that. So really what you need to do in TypeScript is you have to be more specific about the object. I could do this. I could say, hey, okay, Tim is going to be of type an object, use curly brackets and say, okay, this thing's going to have a name that's a string and an age that's a number. Okay, so literally I have to just like that. That would work. So now if I run the code again, see, now I can log Tim's name property. The problem with that is, like, can you imagine having to type that out every time you create a new object? That would be brutal. So what they have in TypeScript is you have the ability to create what's called an interface. Again, this is more strictly a TypeScript thing, because again, there's no typing in JavaScript, so you don't have to worry about this. You would just make objects. So we can call this a student interface. Okay. And then what we can do here is I can say a student is something that has a name, that's a string, and an age, that is a number. Okay, and now instead of typing student as an object, I can type student as a student interface. Okay, and since it matches the student interface, everything checks out. Okay, so again, Tim is going to be exactly what I said it would be, an object with these two properties, because that's what the interface is saying. It's saying, hey, the things that match this type are objects that have these properties. Now I can add, so now actually this should work again. And again, the other way I can access the properties, if I do console.log, I can do Tim, but instead of using dot notation like I did a second ago, I can use square brackets, kind of like an array, except I pass it a string. In this case, I'm passing, the name of the property. So I'll say age. So I'm passing. I could do that with name. I could do that with age. So either name or age could be accessed through this dot notation or through the square bracket notation. Either way works for accessing the properties. The square bracket notation can be really useful when you don't know the name of the property up front. Okay, so you want to dynamically say, okay, well, let me use a variable that has a string in it to determine which property I'm going to access, and then you can use the square bracket notation. The dot notation only really works if you know exactly which property you're going to use, although that's generally the easier one to use, because I didn't have to type the 2 quotation marks, I didn't have to type 2 square brackets, just 1 dot. Okay, cool. And this is referred, when you ever use dots and you just keep using dots over and over again, that's referred to as chaining. There are going to be situations where you might run into errors because a property that should exist doesn't exist. So there is a feature called optional chaining in JavaScript, where I can put like a question mark after the dot. Actually, I think it's going to be before the dot, like that. And then what will happen is if name doesn't exist, it won't throw me an error. Okay, so it's just something to be aware of. Cool. So that's how we access the properties of our object, and our object can have anything. I can even add properties after I've created the object. So after we've created Tim, I can be like, Tim has a height. Okay, and we'll say Tim height is 5'6". Okay, it's a tall 14-year-old. Okay, but now what's it complaining about is that height doesn't exist. Okay, because again, if I take a look at my student interface, there is no height. So let's add it. So I'm going to say height, and I wrote it as a string, so we'll type it as a string. Okay, so it's no longer complaining about this because Tim should have a height, but now it's complaining over here is that I created an object that doesn't have height. Because whenever I write an interface, it assumes that these properties must be part of the object. Okay, so for me to designate it as an optional property, meaning that can or may or may not be there, okay, I have to put a question mark at the end of the property name. Okay, it's still called height, but the question mark tells TypeScript that this may or may not be there. Like this, like don't complain if it's not, because I told you it may or may not be there. So in this case, when I first create Tim and there is no height, it doesn't complain. But when I add height, it doesn't complain either because it knows it could be there. Okay, so again, the interface will determine how we create our object. And I can add any kind of properties I want. I can add functions. Okay, so I can sit there and say, every student has a greeting. They say hello, and all it is, and a greeting is just going to be a function that takes no arguments that returns a string. Okay, so now it's complaining that Tim has no greeting property. Okay, and so I type in greeting. Okay, and then I'll say, okay, hey, okay, there's a greeting, and greeting is going to equal a function that returns the word hello. Because see, that's a function that returns a string. It matches the type. Okay, and that's all well and good. Now, let's say I want to create lots of students, though, having to type this whole thing out for each student can get really frustrating. So maybe I'd like to write a function to create my students for me. Okay, so I might do something like this. So I'll comment out Tim for a second. Okay, and actually comment out all this. And I'll create a function called makePerson or makeStudent. Const makeStudent, and makeStudent it's going to take in a name and an age, and that's it. Okay, and actually let's do this as, I just wrote that all wrong. Let's write it as a true function. Function make student is taking in one argument that's name, that's a string, and age, which is a number. And what I should get back is a object that matches the student interface. Okay, so I could write this function. So the idea is I got to take the function will take in a string and a number, and I got to create a function, a student. So then what I'll do is I'll say return a new object, and I got to make sure it matches what a student interface says a student should be. So I can say, okay, now I could do, hey, there's a name property that equals the name variable, but doesn't that look redundant, having to type name? Again, we don't want to repeat ourselves. Luckily, JavaScript and Typescript give us this little shortcut where I can just put in if I already have a variable that has the same name as I want for the key, I could just put that variable there and it'll automatically treat the name of the variable as the key and the value of the variable as the value. So just writing name is the same as me writing name : name, because the variable here, name, because it's a parameter going into the functions, the input of the function already has the name. So I can do the same thing with age. Okay, and then I just have to give it a greeting function, and we'll just say, hey, every student by default says hello. Or says, yeah, hello. And there we go. Now I have a function that when I use it will give me back an object that matches the student interface. So if I were to create many students, so if I were to create like a class, like let's say here, a list of students, so const list of students, which is going to be an array of objects that match the student interface. Okay, now I can write this array, and then just each thing in the array has to be an object that matches the student interface. Okay, so I can be like make student. First we'll add Tim. So Tim, who's 14, because this function is going to just return a student. Okay. Let me see why it doesn't like. Oh, I wrote too many equal signs. This should be a colon. There we go. Okay, so again, this list of students variable will be an array of students that match the student interface, because again, whatever goes inside the diamond is what should be inside the array. Okay, and then I say, okay, let's make a student called Jimmy, who's also 14. Let's make a student called Susie. That's 15. Okay, etc. Okay, now I have a list of students, and see that's a lot easier than me having to sit there and create each student individually by creating one object at a time. Okay, so this pattern is referred to as like me creating, like, you could think of it as a factory function or a constructor function, but typically we do this in a slightly different way. But just to kind of illustrate a few things, and let me just console log. Okay, list of students. So you can see that, hey, all of our students are in there as objects. And see, basically this array is an array of objects that match the student interface. They have a name and an age and a greeting. This is all good, but in order to get to this point, to get to this nice point, I had to create two things manually. I had to create this interface so I have the right type that I can use, and I had to create this function to simplify the act of creating. Now, there is a way I can just do this all in one fell swoop, so that way I don't have to create I can, instead of creating a type and a function separately, I can kind of do it in one sort of way of describing what a student is. This is where we start getting into what's called object-oriented programming, okay, where we sit there and we start trying to create abstractions over ideas. So in this case, we're trying to create something that represents the idea of a student. We kind of did that with the interface and the function, and it works. Like this works. This does what we need to do. But we could have simplified this by creating what's called a class. So instead of having to create an interface and a function to make my life easier to create many students, first I have to define what a student looks like, and then two, create a function that creates students, so that way I don't have to manually do it myself over and over again. What we can do is you can create a class. Okay, a class basically allows you to create a blueprint for an object, but it also ends up working as a type. Okay, so basically you end up creating the function to create the object, and you end up creating a type that you can use for typing, all by just doing it once. Okay, which is pretty nice. So I would say, hey, let's create a class called student. Okay, and then here in the curly brackets, and classes do exist in JavaScript. And the way we're going to write them is the same way you would pretty much write them in JavaScript, for the exception of any typing that I do. The only difference is in JavaScript, you don't care about typing, so you wouldn't need to use the class as a type. So classes are even extra beneficial when you're working in TypeScript because they double as a type. So I can say class student, and what you do is you would define a function called the constructor inside here. Okay, and basically this constructor function would just take the signature of, like, basically what I would have done as the make student function would be this constructor function. It's the thing that, hey, whenever I make a student, this function is going to run and do the building. Okay, so what I'm going to do is I'm going to say, hey, every time we make a new student, let's start off by bringing in a name, which we'll say is a string, and an age, which is a string. Okay, like we did here. I don't have to type the return value because it's implied that the constructor always returns an object of the type. So in this case, the constructor will always return a student, okay, because it's part of the student class. So I don't have to necessarily type the return value. Not even sure if it would let me, but let's see if it does. So basically, if I wanted to be really explicit about it, I would just say, hey, it's going to return a student object. But yeah, no, it doesn't look like I can do that. So these type annotations cannot appear on a constructor declaration. Yeah, so it's not necessary on a constructor because it's implied. It's like there's no question about what that's supposed to return. Okay, and then we just write the function here. So in this case, instead of me returning a new object, though, the object is already created. So the constructor works a little bit differently. Like here, I returned a new object because it was a function returning an object. What I'm going to do here is that an object is just created, and then this function is really a function of the object that just got created. And what happens is that when an object calls a function, I can use what's called this. This is a keyword that refers to the object itself. So that way we can say, okay, hey, define the properties on the object. So I'm going to say, hey, the object that got created, this has a property called name, which should equal the name that was passed into the function. Okay. Okay, this dot name or this dot age, okay, equals, okay, age. Okay, and what it wants us to do is here, it just wants us to kind of declare the properties up here. So we want to sit there and say, hey, this has a name property, which is a string, and we have an age property, which is a number. Usually in normal JavaScript, slightly different, you don't have to pre-declare the properties. Okay, and just because I didn't see how TypeScript can catch your errors, because I accidentally typed age as a string when I really want to type it as a number. And because I got those error messages, I was able to kind of get that clarity. Sometimes some of the errors you're finding are errors you have because you're doing it in TypeScript. But essentially, see, this code right here does everything I did with everything else. Okay, it does. It basically does all of these things. Okay, and then again, if I wanted to define things like height and greeting, now if I wanted to define the greeting property, I would just actually just write it as an additional function inside the definition. So I would just say, hey, greeting. This, students have a function called greeting, and all it does is return hello. So there's our greeting function. And then I think I can just define height, but I don't have to necessarily immediately define it. Height, which will be a string. Okay. And there we go. Now I have essentially the same thing as I did by using this interface and this make student function, but now I have one thing called student. So now I can instead remake, so if I were to create this list of students again and call it list of students 2, and in this case, instead of an array of student interface, it's going to be an array of student. All I would do is I would just replace each of these with new student. Okay, so whenever you want to use a class and create a new thing of that class, you use the new keyword. New keyword means, hey, I want to invoke the constructor function. So it'll take the student class, make a new object, and immediately run the constructor function to add properties to that object. Okay, so essentially this is going to do the same thing. It's going to create 3 objects that are students and match that student class. Okay, and because I typed it as student, it knows that, hey, these are all students, so that works typing wise. So I end up in the same place. So again, if I console log this, so let's console log, let's copy this line, console log list of students 2. Okay. Okay, so once, let's see here, can I just make that out? Do the same thing over here, or I just put a question mark? I think we do. Let's try that. Yep, there we go. So we just have to put the question mark to make it optional. Okay, and see, I still get 3 objects that are all students. Okay, name, age, but there's a spot for height in case, that way I know I could define a height. And yeah, but I get the extra benefit is that when I print them out, it actually shows the definition of like what is a student. So I can see that this was made from the student class, okay, in the output that I logged. So this is pretty convenient and pretty nice. So that's a better way to make your objects in TypeScript, because you get the benefit of not having to write like a function to make the thing if you're making a lot of those items, and you get the type built in when you build the class. Okay, and now I can create all the student objects I want pretty easily, and then they work just like any other object. Okay, but typically that's what's going to happen. Generally, you're going to have objects that represent a single thing. So in this case, a list of students, each student is an object, but the list of students is an array, because of the, generally we have the students in a particular order. So imagine like an inventory list. So the inventory items would be objects, but the students, the actual list of inventory would be an array. And that's sort of the first step in thinking about like how you work with data, because a lot of it's about just thinking about how we're going to model real world things, again, like a list, like a classroom in our code, so we can create programs to deal with that situation. Okay, so that's what objects are. So we've learned, how do you create an object, which is just curly brackets. So again, when we created the student interface, it's just curly brackets. But in TypeScript, we need to define the shape of the object, which we can do using interfaces. Okay, if we plan on making lots of that object, like if we're just making one, then an interface and an object that's fine. You don't need to create a whole class. But that's referred to as a singleton. But if you're going to be making many of the object, okay, we might want to make a function to help us build the object. And then we can do both of those things in one fell swoop by creating a class. Okay, with a class, we can define what does the object look like, what kind of functions does it have. So I can just add functions. These are called methods right in the class. And then I can define the properties, define the constructor to set up those properties when I create a new student, and just do that all in sort of one abstraction. Okay, and yeah, so we'll go deeper into classes in a future video, but that's a quick go around on objects. I do have other videos on objects. So if you look up like Alex Merced objects masterclass, you'll see sort of like a deep dive into sort of object syntax purely in JavaScript, so you don't have to worry about the typing. You can just see sort of like objects doing their thing. But yeah, I mean, otherwise, again, this would be, all you would do is just remove all the typing pieces, and now you would get the JavaScript version. And if you want, try that out. Try it out in TypeScript, try it out in JavaScript, create some objects, create some arrays of objects, try looping over them and making a change at the same, like, you know, making sure that like each person's age goes up by 1 year after a year or something like that. Play around with what you've learned, because that's how you get more comfortable with what it can do. My name is Alex Brissett from alexbrissettcoder.com. Have a great day and enjoy.